We have SQL Server running on Ubuntu 22.04, but we know that doing the Linux equivalent of clicking next, next, next isn't good enough for SQL Server. So what do we need to do? Let's find out together. Welcome to this video on SQL Server on Linux. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the prior video in this series, we installed SQL Server 2022 on Ubuntu 22.04 and made sure we could connect to the database. In this video, I want to talk about SQL Server on Linux specific configuration settings and performance options. As a point of clarification before we dig in, this is not the same as changing database and instance properties via SQL Server Management Studio or Azure Data Studio. I have a video covering that topic in a little bit of detail, and it might be popping up overhead just about now. You'll want to check out that video if you're new to SQL Server. But I'm assuming you're an old hand and have configured plenty of databases in your day, so we're going to focus on the areas where SQL Server on Linux is different from Windows. Because example is the school of mankind and they will learn it no other, I think it's best that we just jump to the demo. I've started back up the Ubuntu virtual machine that we used in the prior video. In the first part of this video, I'm going to focus on configuration using mssql-conf. By the way, in case you don't know where the mssql-conf executable is, I recommend installing a tool called plocate. Once it's installed, it'll take a few moments to build a database of file locations. I've used variants of the locate service for more than 2 decades now, and I love it for how simple and quick it is. It builds a file database on your system and lets you perform quick searches. So, for example, now that it's completed the database build, I can enter the following command to find any files with mssql-conf in the path. We can see that on Ubuntu, SQL Server installs in /opt/mssql by default, and inside the bin folder, we have mssql-conf. Let's switch over to that directory now. I can run mssql-conf with the list parameter and see all of the possible options. And it's a lot of options. We're going to go over some of these during the series, but it may be worth your time perusing the list just to see what you can do with this. For example, in the prior video, we used mssql-conf to set SQL agent.enabled to true. We can see that there are several other SQL agent related settings, such as your default database mail profile, where you want the error log written out to, the max number of rows in job history, and the like. Most of these SQL agent settings are things you can modify from within SQL Server Management Studio, though you can set the SQL agent service to wait until all databases are online before turning on, using the startup wait for all DB configuration setting at the bottom. The next thing I want to mention is how to set the instance collation. We can use the set collation command to do so. You'll need to know the proper name of the collation so you aren't just selecting it from a drop-down list. Now, I just happen to know the name of a useful Windows collation for databases primarily containing English, so let's paste that in. And we get an error message. Well, it's trying to make a new model database, but because the SQL Server service is active, we can't replace the MDF file. So the way around this error message is to shut down SQL Server first, which I can do with system control. After that, I can run the command again to set collation. Then I'll need to type in the collation one more time. After I've typed in the collation, I can strike enter and we see all kinds of messages fly by us, indicating that this command worked as expected. After a moment, we'll see that everything is done, and I'm going to check if SQL Server is running. It's not, so let's restart the instance. Now, when I check the status a second time, I can see that SQL Server is active. There are plenty of things we can do in addition to this, and we'll explore some of the other configuration options in later videos. I'll also leave a link in the description below to a Microsoft Learn page covering mssql-conf. The next thing I'd like to do is talk about some performance best practices for SQL Server on Linux. Let's go to the best practices guide, as I won't be able to show you everything on this machine. The guide starts off with some storage information recommendations, most of which I won't be able to show you directly. Their first recommendation is to use a RAID configuration. There are pros and cons to different RAID levels. For example, in this first bash script block, they use RAID 5 for the data drives, RAID 10 for the log files, and RAID 0 for tempdb. RAID 5 and RAID 10 are both very common formats. RAID 5 requires at least 3 disks and uses a parity segment to make it so that you can survive the loss of one drive. Its best use case is scenarios with occasional write but heavy read activity, so maybe something like a data warehouse or your backup files. RAID 10 requires at least 4 disks, as you're striping data across 2 disks and you're mirroring that to the other 2. RAID 10 gives you great performance for both reads and writes, and I do recommend that over RAID 5 for transactional database data files. tempdb is in RAID level 0, meaning that we are striping the data across 2 or more disks, but don't care about mirroring. This makes sense because if a drive fails, we don't really care about the data on that drive. A restart of SQL Server is going to flush tempdb anyhow, so we treat all tempdb information as ephemeral. The next bash shell script block shows how to create a log volume, making note that the stripe size of 64K, which we can see from the chunk parameter, matches the S unit value of 16 times the disk block size of 4K. The S width is 48, as it is S unit times the number of non-parity drives. There are 6 devices total in this sample RAID 10 configuration, so 3 drives are mirrors, and we can ignore them for this calculation. Scrolling down a little bit, SQL Server supports ext4 and XFS for file system, but Microsoft recommends that you use XFS to host your SQL Server files. XFS is the default file system for Red Hat Enterprise Linux, but not for Ubuntu and other Debian-based distributions. They typically default to ext4. Now, here's where I admit that I'm certainly not an expert on Linux file systems, but my limited understanding, based on people who have tested database workloads on ext4 and XFS for MySQL, Postgres, and even SQL Server, is that, frankly, they'll both perform similarly well. The main reason I could see going with XFS over ext4 is that a file in ext4 is limited to 16 terabytes in size, whereas you can create a file up to 8 exabytes in XFS. So if you have a very large database with at least 16 terabytes of data in a single file, you'll need XFS. If your SQL Server databases are nowhere near that large, or if you can definitely split the data into files smaller than 16 terabytes, then you're okay with either route. That said, there is one additional performance gain that you can get later on in this article if you do happen to use XFS. Skipping past persistent memory, mostly because of how uncommon it is to see anyone with PMM in their servers, let's talk about open files. You'll definitely want to set up the open file limits. The note here indicates that this is how you make a change for RHEL, but let's try it on Ubuntu. I'm going to open up the configuration file in VI. As we can see, there's one entry in the configuration file right now, a soft stack limit of 8192. Let's add in a hard no-file limit of 32727 and a soft no-file limit of 16,000. By the way, you can add a new line in VI using the O key, lowercase o. Then I'll escape, strike Z, and write the file to disk. We don't need to reboot the machine, though we will need to close all active sessions and restart SQL Server. So you may as well reboot the machine as far as I'm concerned. Back to the guide. The next section covers turning off A-time for your SQL Server drives. Turning this off does help performance, so it's worth doing. Then there's a section here on forced unit access for data durability. This is the performance gain I hinted at earlier. If you want to dive in and learn more about forced unit access and how everything works, the link here takes you to a Bob Dorr blog post covering the topic. I'll also have that link in the description below. The next section in the guide covers kernel and CPU level settings. The first recommendation is to use tuned-adm, a system tuning service for Linux, to optimize performance. They show us here a profile for Red Hat Enterprise Linux, but let's see what we get on Ubuntu. I'm going to install the tuned-adm service now. It takes a few moments to install and prepare, so I'll be patient, for some definition of patient at least. Okay, now it's done and we can move on. There's a manual page for the tuned-adm SQL Server profile, which we can access at tuned-adm-profiles-mssql. There's not much in here, but it does note files in /etc/tuned-adm and /user/lib/tuned-adm. Let's navigate to the latter folder. Performing an ls command, we can see that there are a fair number of profiles available to us by default, including one for SQL Server. Let's run ls again, but this time specifically on the mssql folder. We can see one file called tuned-adm.conf, so let's open that up. There's not a lot here, and in fact, Microsoft recommends commenting out the bottom 3 lines for any Linux distribution with a kernel greater than 4.18. And for Ubuntu 22.04, we're going to be at kernel 5.18 by default on installation, and you'll probably be at a higher number if you install updates. But what's strange here is that we are soon going to set 2 of these values again in syscontrol, so I just leave these in place. Returning to the performance guide, we can see that these settings are quite a bit different than what we get in the config file by default. I don't see anything that strikes me as absolutely non-go for Ubuntu, though I will admit that I'm not a tuned-adm expert, so take that for what it's worth. Scrolling down to the CPU settings recommendation, this block basically says that you're in performance mode rather than balanced or energy saving modes. This is also something that regularly hurts the performance of SQL Server on Windows, when people would use a balanced or a power saver plan on a Windows server running SQL Server. For SQL Server on Windows, you always want to use a high performance power plan. Similarly, for SQL Server on Linux, focus on performance rather than energy savings. In disk settings, use blockdev to set the disk read ahead to 4K. There are also some listings that you can modify in syscontrol. If you used the tuned-adm profile that Microsoft recommended above and you did not comment out the last 3 lines of the default profile, those settings are already in place. After that, Microsoft recommends disabling auto NUMA balancing. This is another default in the tuned-adm profile. The next is kernel settings for virtual address space. That is, the number of discrete areas mapped in memory, rather than some indicator of how much memory SQL Server can get. In my Ubuntu tuned-adm profile, the default max map count is 800,000. This guide's recommendation is 1.6 million. The important thing is to pick a large enough number, and the minimum recommended number is 262,144. So both of these may be viable options, but if you want to play it safe, bump it to 1.6 million. After that, they recommend leaving transparent huge pages enabled. They're on by default in Ubuntu, so nothing to change here. Now let's talk about network settings. They recommend setting your NIC receive and transmit buffers to 4 kilobytes, and they show how to do this. In my VM, let's run the diagnosis command and see what we get. Running this, I can see that the preset maximum for my receive buffer is just under 18 kilobytes, and for transmit, it's exactly 2.5 kilobytes. My current settings have a receive at just over 9 kilobytes and a transmission of 170 bytes. What the transmission maximum tells me is that I can't go up to 4 kilobytes, as this virtual NIC caps out at 2.5. Also, I'm already receiving more than 4 kilobytes in a chunk, so I think I'll leave that alone. Nonetheless, let's try the command to set transmit to 4 kilobytes and see what we get. Okay, that's a perfectly reasonable error. So let's try this again, setting it to 2560 instead. That looks better, and I'll run the original command again to confirm our settings. And we're good to go. After that, they cover jumbo frames. This is a setting I won't be able to replicate because I don't have a switch capable of it. So let's talk about it instead. The idea is that a typical TCP packet maxes out at approximately 1500 bytes of user data. So to send one 8 kilobyte page of data, you need 6 packets. If we bump up the size of a packet datagram to 8 kilobytes, we can pack an entire page within one packet and send it to the client in a single go rather than over multiple packets. The upside to doing this is that you have less CPU overhead to send data over the network. The downside is that it takes longer to assemble your payload, leading to slightly higher latency. For relational databases, we are much more concerned with throughput than latency, so it's actually a good trade-off for us. But why 8060 and not 8192? The answer to that is SQL Server can hold no more than 8060 bytes of user data in a single page. The remaining bytes are internal details that don't get sent over the network. Though, to be honest, I'd still set it at 8192 and keep it at a nice base 2 number. If you do enable jumbo frames in Linux and across your network, be sure to run spconfigure in SQL Server and set the network packet size to match your selected value. Otherwise, SQL Server will continue sending out smaller packets even if your network can support jumbo frames. The next command is around adaptive receive and transmit IRQ coalescing. I'll quickly scroll past this one since I can't try it out on my VM. The fourth networking option is to enable receive side scaling, using a value of 8 as the example value. In my VM's case, let's run the command to check this value. It turns out that I'm already at 8, so there's nothing to change here. The final bit of guidance is around IRQ affinity, so you can read up on that if you so desire. And after that, there's a note around using blockmq, a block I/O queuing mechanism enabling fast storage devices to queue and submit I/O requests to block devices simultaneously and take advantage of the parallelism that you get by having a drive manufactured in the past decade. There's an easy way to tell if you have blockmq enabled, and that is to look at the scheduler list for your storage devices. Here is mine. The only result I get here is MQ deadline, which is a multi-queue deadline scheduler. Ever since kernel 3.19, blockmq is the only option available for NVMe devices like my drive, so there's nothing to worry about here. For a server running on a SAN, however, it would be worth making sure that you have blockmq enabled. After that, there's a note on swap files. My general feeling on swap files is I don't like to use them for SQL Server instances. No matter how fast your disk is, it's still an order of magnitude slower than memory, if not more. Instead, load up on RAM just as you would on Windows. Enabling process affinity is the next recommendation. It's liable to give you a moderate performance boost, especially if you have multiple NUMA nodes. I wouldn't expect to see any major performance gains, but in the right circumstances, it can improve things a bit. Multiple tempdb data files, however, is a no-brainer. Use the same recommendations as exist for SQL Server on Windows. If you have 8 or fewer logical processors, create that number of tempdb data files. If you have more than 8 logical processor cores, start with 8 and add in groups of 4 until your contention is at acceptable levels, making sure not to go above the number of logical processor cores you have. All tempdb data files should be the same size to ensure that SQL Server hits each of the data files equally. You should only have one tempdb log file, however. The final recommendation they have is to set the max memory. I can use the free command to see how much memory I have on my system. This tells me how much RAM I have on the VM, and I can see how much is currently available versus what's used. My scenario is a little weird because I'm using a VM with memory auto assignment, so the number can increase and decrease based on what I'm doing. For a real server, you'd want to allocate a fixed amount of RAM to a VM, or if you're running it on bare metal, you already have a fixed amount of RAM. By default, SQL Server on Linux caps itself at 80% of the physical amount of RAM. So if you have a lot of RAM on a box, you might have a fair amount of it doing nothing because SQL Server won't use it. Basically, we want to leave some percentage of RAM to the OS and to other tasks that are running, but let SQL Server have the rest. Normally, I'd recommend leaving somewhere between, say, 3 to 8 gigabytes of RAM for operating system duties, depending on how much RAM your box has. There are some guidelines you can find for max memory for SQL Server on Windows that might serve as a reasonable starting point. Let's say that I want to set the max memory for SQL Server to 4 gigabytes. I could do that in SSMS or directly at the command line using mssql-conf. And that's all we've got for the performance guide. There is one more thing I want to make note of, and that's where you can find error information if you're troubleshooting SQL Server on Linux issues. SQL Server saves log data to the /var directory. For the default installation on Ubuntu, here's the location. For other distributions, your install location might be different, so you may need to search for it. The error log file is the latest log, and then SQL Server cycles error logs based on your settings, saving them in numerically increasing order. If there are any dump files, they'll also be in here with an extension of .mdump. By the way, this is the same as Windows, it's just in a different directory. I'll include a link to the troubleshooting guide for SQL Server on Linux, which includes a few more details about what to look for. That was a lot! Over the course of this video, we walked through quite a few configuration options for SQL Server on Linux and demonstrated most of them in our Ubuntu VM. I couldn't show everything due to my configuration, but the guide is there for your perusal. We'll have links and show notes in the description below, and until we see each other in the next video, take care.